Hello and welcome to 5.3, Solve Systems of Equations by Elimination. As the name says, we need to eliminate one of the variables so that we have only one variable to deal with. Once you solve for one of them, you will back substitute it to find the other variable. Okay. So another name for elimination method is also addition method. So I'll just write that here. Meaning we try to eliminate by adding the two equations. Okay? So let's call this equation 1 and equation 2. Now look at the two equations. If you added the two equations, is there a way to eliminate one of the variables? All right, this is the first problem. So it's conveniently set up for us to see that if you added the two equations as they are, the plus y and the minus y, they're opposites, right? Equal and opposite terms. So they will cancel off, thus eliminating one variable. In this case, we eliminate the variable y, right? So we're doing elimination by addition. So let me just write that out here. Equation 1, okay, is this plus equation 2. X plus y equals 10. X minus y equals 12. We're adding these two equations. Okay. I put that so that it draws your attention to add them. They are lined up nicely, so as per their like terms, so you can just add them vertically down. X plus x is 2x. Y minus y, yes, that's where they cancel off. Okay. And 10 plus 12, 22. Okay. Right there, you eliminated the y, leaving us with 2x equals 22, a single variable in the equation. Very easy to solve. You divide both sides by 2. Do you get x equals 11? Okay. Now that we got x, we need to find y. You could choose any one equation, either equation 1 or 2, to plug this x value in order to find your y. I'd like to choose equation 1. So I'll say substitute x equals 11 in equation 1 to find y. Okay, x plus y equals 10 is the first equation. Let's write that. And here, in the place of x, I plug in 11. We need to move the 11 over to the other side. So subtract 11. Y equals 10 minus 11 is negative 1. That was a breeze, isn't it? We found x and y by addition, and they were lined up nicely so that it didn't take us long to find x and y. And we come back and say the ordered pair x was 11. So 11 comma negative 1 is the solution to the system. I'll leave the check to you. I'll just mention here, please perform check. Okay. All right, well, let's look at the another problem. Solve the system by elimination. 2x plus y equals 7 and x minus 2y equals 6. Look at your two equations. If you just added them, does that eliminate a variable? Well, let's see. If I added these two, I get 3x. If I added these two, I actually get a negative y. So neither of the variables cancel off. What do we do? Well, we can algebraically manipulate this problem so that the variables will be equal and opposite in sign. Let's see. So if I took the first equation and multiplied both sides by 2, I will not affect the value. But when I multiply both sides by 2, you know, the middle term here for plus y, when I multiply each one by 2, that becomes a positive 2y. So 2y and 2y are matching, so they're equal terms with opposite signs. That means when I add them, they will cancel off. So we plan by manipulating the given equation So I'm going to take the first equation, multiply it by 2. So let me write the equation first. 2x plus y. Give it a bit of a space. 2x plus equals 7. And that gets multiplied by 2. What about equation 2? Equation 2 stays the same. Okay, it's like you multiplied it by 1. It just stays the same. So that's x minus 2y equals 6. Okay. Let's distribute it here in the next step. So 4x plus 2y equals 14, right? When we multiply by the entire equation by 2, every term gets multiplied by 2. So that is the first one. Then you have x minus 2y equals 6. You got the second one. Remember, we are adding this equation, these two equations. So I put a plus there so you can remember we're adding. 4x plus x is 5x. As expected, these two will cancel off. 14 plus 6 is 20. Divide by 5 on both sides. You get x equals 4. Once we get this, we can go back to the original equation, any one of the original equations, plug in for x and find y. Once again, I find equation 1 to be more suitable because y does not have any variables. So if I simply subtracted the 2x on both sides, I get the answer. So I have to substitute x equals 4 in equation 1 to find y. Okay, so equation 1 is 2x plus y equals 7. 2 times x plus y equals 7. Let me plug that in as 4. 8 plus y equals 7. We were trying to get y by itself, so y equals -1. The ordered pair 4, -1 is the solution to the system. If this answer looks familiar, you're right, because we used the same problem in the previous section, but solved it by a substitution method. Here we're using the addition or the elimination method to get the solution. Obviously, there are two different methods, so they should give us the same answer. So we got that. And we did the check there for this problem, in fact. So we know this is definitely the answer. Let's look at another one. Solve the system by elimination. 3x minus 2y equals -2. 5x minus 6y equals 10. Again, check to see if your variables will cancel each other when they add up. Well, for one thing, I do see that they are of the same signs, right? 3x, 5x, same sign. They're not going to cancel. -2y and -6y. Well, they don't match anyway, so they're not going to cancel anyway for both the variables. But more so because they have the same signs, right? Even if they had the same terms, 2y and 2y or 3x and 3x, they still won't cancel because they don't have opposite signs to cancel them off. That's something we need to remember when we manipulate our equations. Okay, let's look at the equation in 1. Let's look at x, it's 3x, and I look at the other one, 5x. I don't see one to be a multiple of the other, so that doesn't really help us. So let's go to equation, to the second variable, y. I have a 2y and a 6y, right? 2 and 6 are multiples of 2. So if I multiplied 2 by 3, I get a 6y, right? They will match. So I can already see that if I multiplied equation 1 by 3, they will match. But there's one more thing missing, opposite signs. So I need a negative and a positive. I have two negatives right now. So if we multiplied by a 3, but not just a 3, but by a -3, we might get opposite signs, and that will help us to eliminate the y. So that is our first step. So I'm going to multiply equation 1 by a negative 3. So it's negative 3 for the first equation. Second equation, no change to it. It's as if we multiplied it by a 1. It's not always going to be the first equation that you will manipulate. It so happens that way. Whatever works for you, either the first or the second, is totally fine. So let me rewrite them after distribution. So that's going to be negative 3 times 3x is negative 9x. Negative 3 times negative 2y is positive 6y equals negative 3 times negative 2 is positive 6. 5x minus 6y equals 10. Remember, we're adding them because we already took care of the minus when we multiplied. It's always adding. That's why it's also called the addition method. Okay, so negative 9x plus 5x, negative 4x. This cancels off. Equals 6 plus 10, 16. All right, now we got everything in x. Divide both sides by negative 4. Remember the negative 4, not just the 4. Okay, so x equals negative 4. That's our answer. Now let's see which equation is suitable. Well, both equations have a coefficient, so it doesn't matter which one we choose. We've always used equation 1. Just for variety, I'm going to use equation 2. Okay, so we'll say substitute x equals negative 4 in equation 2. Okay, you might very well plug it in equation 1. 5x minus 6y equals 10. 5x minus 6y equals 10. Plug in negative 4 in the place of x. Negative 20 minus 6y equals 10. Add 20 on both sides. That will eliminate this one. Negative 6y equals positive 30. Divide both sides by negative 6. And you get y equals negative 5. Well, x is negative 4, y is negative 5. The ordered pair, negative 4, comma negative 5, is the solution to the system. And please always check your solution. Please perform check. So that's our elimination method. I will see you in the next video. Bye.